Hello everyone. In this video, I'm going to talk about the grid search method, which is used for selection of model hyperparameters. I mean, those parameters that we have to provide and the model, the learning algorithm is not going to determine those. So this is an exhaustive search, and basically whatever parameter that you want to change in your algorithm, you provide it, and then allowing this exhaustive search method to go and look at all combinations of the parameters, right? And then for each one of them, run the training method, then get some metric, and then finally compare all these metrics and see which one is better. So it's an optimization task, but an exhaustive one, right? It's basically searching for each and every one of the numbers. It's not like super intelligent, right? Because it's not really easy to do any predictions here. So it's an exhaustive search optimization task for the model hyperparameters. So here I do it very simply. I bring in again the support vector machine and data set from Scikit-Learn, and then under model selection we need this function grid, or this method grid search CV. Okay, we bring this, which is going to do the grid search for us. So again, I use the flower data that I used in my previous video on the performance metrics. I get the features, I get the targets, right, or the labels. And then here for the support vector machine, which is svm.svc, and I can give it a name, svc, so I can refer to that in my grid search. I choose two sets of parameters to change. One is that regularization parameter C, which here can be 1 or 10. So two numbers, and then my kernel, which can be linear or a radial basis function, RBF. Okay, so I have two options here, two options there. So it is going to search over 4 combinations: linear with C of 1, linear with C of 10, RBF with C of 1, RBF with C of 10. And among these 4 selections of these hyperparameters, it is going to determine which one is the best, using which metric here, using the scoring metric of accuracy. So I define my parameters like a dictionary. I pass it to it. I pass my classifier, my algorithm, and I pass the scoring method. And then ask this to check all of the scenarios and tell me which one is the best. It does that, but before that, you have to pass to it your data X and Y. If you break your data into training and testing, make sure you only pass what? Training data here when you do grid search.fit. Okay, make sure you never pass the testing data. Once it does it, now from this, you can go grid search dot best estimator dot get parameters. So one of the things that this guy gives back to you is the best estimator. And that best estimator, which is an SVM, it has some parameters, so you can get the parameters out of the best estimator. Okay, and then these parameters, you can pass the keys to them. One of them is the C value here. The other one is what? The kernel. So you can get the kernel out of the best parameters and the C value out of the best parameters. The other thing you can get from this grid search is called the best score. And that is the highest value of accuracy that you could achieve, right? And then you can show all of them as a print message. So here I'm going to go between 2 kernels and 2 C values and see which combination is going to give me the highest accuracy. And as you can see, a C of 1 with the linear kernel gives you 0.98, which is what? The highest accuracy. Now, clearly, this is a time-consuming thing, right? So if you have more options here, so I have 0.01 and then 0.1 and then 1 and then 10, right? And here I have more kernels and so on. So now you have what? Remember, you have 4 C's and 2 kernels, so you have 8 combinations. So the more that you have parameters and the more options you have for the parameters, this search is going to take more and more time. So in general, the grid search is what? As the name exhaustive says, it's a time-consuming operation. But if you have to do it one time, you are probably not super concerned about the runtime, right? So you just go ahead and run it and see which combination is better. So here I have more options for C, see which one is better. And you still see C of 1 is giving me the best data, although here I provided the smaller C's. Seems like C of 1 is the best, and still my linear kernel is doing better job than the radial basis function. Okay, so here my best params, if you print it, it has basically 8 sets of data, and then I can get again out of it the best estimator, the parameters of it, the best score, and so many other things. So this is a simple short video on how to select the best set of hyperparameters using what? Grid Search CV. Hopefully this video was useful to you, and I'll see you in the next video. Thank you.